Hey guys, I just wanted to make a quick video to show you how to balance chemical reactions. You probably did this in middle school at some point, but I want to give you a quick refresher. So here's a little, basically the notes that we went over in class with the in-person students. So remember physical and chemical changes. Physical changes are a change in a substance that only affects its physical properties. Cutting, coloring, crushing, all of the states of matter changes from melting to boiling to freezing, all those are physical changes. Chemical changes are changes in a substance that affects its chemical properties. Thus, a chemical reaction occurs. And a chemical reaction, remember, it can be burning, rusting, decomposing. And with that, let me make this a little bigger here. With that, you're going to have atoms rearranged and new substances are formed. So remember, in a chemical reactions, they would be represented by like this. By equations, and in this one, anything on the left of the arrow we call reactants. That's what you start with, or your ingredients. Anything on the right of the arrow are your products. These are where your ending substances are, or what is made. And of course, the little arrow means to yield, or that's what we produce. So 2 sodium plus a chlorine molecule yields 2 sodium chloride. That's how we do that. Now, it's important to know when you're balancing chemical equations that the number in front of the element or the compound is called a coefficient, just like in math. And this tells us how many of each substance we need, okay? If you see a subscript, so this number can change. Remember, the subscripts cannot change. So right here, if we have a 2 chlorine, this tells us we have 2 chlorine atoms. And we cannot change that substance, but that number, because if you change that number, you change the element or the substance or the compound. So you cannot change the subscript. If there's only one needed, for example, in chlorine here, you don't put a 1 in front of it. It's kind of understood that so if you don't have anything here, that means that there's just one of those. For example, 2 sodium atoms are needed here, but only 1 chlorine molecule, is needed. Obviously, the plus sign separates these two. If you see that, and you have, sometimes you'll see hydrogens here and hydrogens here. You have to add those together to get your total amount on the left side. So that's an important thing. So again, the notation represents the state of matter. This really doesn't affect balancing chemical equations, but I did want to point this out. You'll see that sometimes on equations, S is for solid, liquid is L for liquid, G for gas. AQ means it's aqueous solution that's dissolved in water. So when you put it all together, for this example, you would have 2 solid sodium atoms added to 2 chlorine gas molecules, or react with 2 chlorine gas molecules to form or to yield 2 solid sodium chloride salts. All right, let's talk about balancing equations. Remember, to balance equations, we do that because it has to balance equations have to we keep from violating the law of conservation of mass, which says matter can either be created or destroyed. It can only change forms. So therefore, the mass of the reactants always equals the mass of the product. So if we're talking about just mass, like 50 grams, you have to, in the product, you have 50 grams in the reactants, you have 50 grams in the product, but also the number of atoms have to balance, and that's what we're going to be doing. If there are 2 sodium atoms in the reactants, there has to be 2 in the product, and that's what balancing equations are all about. Again, the coefficients are what we use to balance the equation. They go in front of the formulas, in front of the elements here. Remember, you cannot, these can change, but subscripts cannot change. Okay. Some rules here. First of all, you have the list, you have your equation. That will usually be given to you. Put the symbols of each element in a column under the reactants. This is kind of the work that I like to show you. It kind of shows you that you're doing the work for it. You can put polyatomic ions together, and what I mean by that is sometimes OHs are what we call a polyatomic ion, or NH3 ammonia is a polyatomic ion. If you see that on both sides of the arrow, you can put it together. If you only see it on one side, you can't do that. But you can do it if it's on both sides. Typically, SO4 is an example of that. You'll see on the worksheet today, NH3, OHs, those are things you can put together. If it's confusing for you, it's not that big a deal. You can still separate them out individually and you'll get the same results. Count the number of each atom on both sides and write it in your chart. And then you go in and change the coefficients to make them balance and reduce as needed. You must be in lowest whole number ratio. So here are a couple of examples. Fe plus Cl2 yields FeCl3. So the chart, I have the reactants over here and the products over here and your elements down the middle. So I've got Fe and Cl. If you look, you have one Fe over here and one, since there's not a number after Fe or before, that means we have one over here. Chlorine, this number here tells me that we have 2 chlorine atoms here, and the Cl3 is just for the chlorine, so that's 3 chlorine over here. Now right off the bat, I see that I'm going to need chlorines to balance. Now if you were to go in and put 2 chlorines, for example, right here, that would give you 4, and that's not, you can't get 4 with 3, starting with 3. So I know I've got to have more than 2. So if I go in and put 3 chlorines, all right, that changes my chlorines here to 3 times 2 is 6. All right, and then I know that I need 6 chlorines over here. I already have 3, so what times 3 is going to equal 6? That's going to be 2. So if you think about 2 times 3 equals 6, and we're going to change that to 6. When I did that, it also changed my iron atoms here. So I got 2 Fe on this side, so I want to change that to 2. Now I've got to get 2 on this side. So the only way you can get 2 on this side is by putting a 2 in front of the Fe. And we're all balanced. One more quick example. NaOH plus CaBr2 yields CaOH2 NaBr. This is an example of having a polyatomic ion, by the way. So sodium is an atom here. We have sodium here. OH, you'll notice OH is here, and it's over here. So we're going to list it together as a polyatomic ion. Calcium and bromine. We have 1 sodium on the left and 1 on the right. OHs, we have 1 here, but notice this in parentheses, if this 2 is just after the parentheses, that means that I have 2 OHs, not 2 calciums. Okay, so we have 2 OHs, but you still just have 1 calcium here and 1 calcium there. Again, that 2 is just because the parentheses are around the OH, that means that both the O and the H have 2 of them. If the parentheses wasn't here, I would have 2 hydrogens and 1 oxygen. But since we have the parentheses, it tells me that everything in the parentheses, it's kind of distributive property in math. Bromine, I have 2 of those over here and just 1. So right off the bat, I want to jump in and look at these OHs. If I've got 2 here, I need 2 over here, right? So if I put a 2 in front of that, that gives me 2 OHs. And it's going to change my sodium to 2. So I've got to go and get 2 sodium over here, right? Because I've got 2 over here now, and if I just put a 2 in front of that, that gives me 2 sodium. And when we put the 2 in front of the NaBr, that gave us 2 bromine. So it's going to change this number down here to 2. And voila, just like that, we're balanced. So that's a balanced chemical equation. So hopefully this helps, help you understand this a little bit. I posted a worksheet earlier. I'll have another one tomorrow for you to work on. The one that I posted today is fairly easy. I think you can do it. I would like for you to show your work on that, and there's a space provided. I would make this little chart like this, just like when we do worksheets. When we've done a lot of math worksheets, I always ask you to show your work. This is how I want to have you show your work. So feel free to email me if you have a question, and if not, I will talk to you guys later.